Am I audible?
Yes, you are audible now.
Sir, 1 minute. मतलब हाँ सर सर बोर्ड दिखाई दे रहा है
Yes, दिखाई दे
मतलब कल ठीक हो जाएगा कल ठीक हो जाएगा यहाँ पे हाँ ठीक है ऑलमोस्ट और
हाँ
सर
ठीक है
कुछ
ठीक है yes.
विजिबल होगा ना सर
Yes, visible है,
ऑलमोस्ट
no problem.
हाँ सर
टुडे कौन से टॉपिक करके आए आप?
ओके सर 1 मिनट सर वही सर क्वांटम था और एक था वो अच्छा सर क्वांटम और इक्विलिब्रियम था तो 1 मिनट मार्कर मतलब कहा गया आज मतलब 1 मिनट था सर यस हाँ सर गुड इवनिंग
Yes, good evening.
पानी बोतल
Today topic
यस
first is chemical equilibrium.
हाँ सर यस हाँ
Yes, let me start. First is chemical equilibrium. What
हाँ
the
सर
basic principle of chemical equilibrium?
sir when suppose a reaction is taking with two reactants suppose I am taking this reaction with A and B okay that means the main basic point of chemical reaction is chemical equilibrium is when two reactant or one reactant gives product okay if that means forward reaction is occurring with some rate when the reactant from product from the product also reactant is forming okay that means the when the reversible reaction is taking place and rate of forward reaction when rate of forward reaction become equal with the rate of backward reaction then it is called equilibrium reaction yes sir suppose I am taking A plus B with taking place for C plus D reaction okay so now am I audible sir
Yes, yes, audible. Carry on.
ओके मतलब आज तो मतलब दिखाई नहीं दे रहा है ना इसलिए सर ए प्लस बी विथ सी प्लस डी सो नाउ रेट ऑफ दैट मीन्स rate of forward reaction will be equal to rate is equal to kf concentration of A into concentration of B okay I'm just taking that rate of forward reaction is equal to kf A and B and again rate of that means now A and B are giving the product C and D. When C and D form, that means almost some amount, then C and D can give the same product. That means A and B product. Then this backward reaction take place. So rate of backward reaction will be RB will be KB concentration of KB concentration of C concentration of D. Okay, and I can we can draw a graph also. That means at initial time, okay, at initial time, only concentration of A and B is there. So when the reaction is proceeding, then A and B concentration of A and B is now decreasing, okay, decreasing exponentially, and at the same time are decreasing. At the same time, C and D are forming. So C and D concentration increasing. At some point, C and D and A and B curve meet, and this point is basically called equilibrium. Yes, sir. At equilibrium, that means A and B giving the same product C and D, whereas C and D giving also the product A and B. Okay, sir. That is the main basic idea of equilibrium. Okay, sir. At equilibrium, we can see that that means that means reaction seeing like stop, but reaction is proceeding. Yes, sir. Sir.
Yes, you talk about the reversible, irreversible reactions. Yes, no?
Sir. My কাপোৰ লাগিছিলে কাপোৰ কেইখন ক'ত থৈছ sir. Yes. Yes, sir.
Yes, what the difference between reversible, irreversible? Example?
Sir. That means in reversible reaction, that means suppose reversible reaction are those type of reaction where from the that means reactant can give the product and product also can give the reactant. Okay, that is called reversible reaction. Whereas irreversible reaction are those type of reaction whereas only one side reaction is proceeding. Okay, that is called irreversible reaction. And sir, suppose I am like forming precipitation reaction. Suppose I am taking AgNO3, sodium chloride and AgNO3. Okay, in this reaction, NaNO3 and AgCl will form. This will precipitate. This reaction is basically an irreversible reaction because from this reaction, that means this is a double displacement reaction. From this reaction, this two we cannot get the same origin product. Okay, origin reaction. But suppose I am taking hydrogen and iodine. Hydrogen and iodine reacting with to form hydrogen iodide. Okay, hydrogen and iodine reacting to form hydrogen iodide. Whereas if we put some temperature, that means hydrogen iodide can decompose to give the same hydrogen and iodine also. This is basically called, this reaction is called reversible reaction, whereas this reaction is called irreversible reaction. And inside reversible reaction, what it is called, that means the process is very fast. Irreversible reaction, the process is very fast. That means the rate of forward reaction, that means the force acting through forward reaction is very much greater than the opposing force. Okay, whereas in reversible process, the opposing force is also almost little bit amount of lower than the forwarding force. Yes, sir. Is it okay, sir? Almost.
Yes. Next one condition is what the difference between thermal equilibrium and physical equilibrium? Yes, thermal equilibrium condition na heat flow.
हाँ सर, am
Yes,
I audible?
yes, carry on.
सब कुछ
अभी वॉइस क्लियर नहीं आ रही, नेटवर्क इशू आ रहा है वॉइस।
हाँ सर, वो मतलब पता नहीं है सर, थर्मल है क्या सर, थर्मल।
यस, नो प्रॉब्लम। देखो मैं आपको बता देता हूँ, थर्मल इक्विलिब्रियम में हीट फ्लो के अकॉर्डिंग एक्सप्लेन करते हैं, ठीक है ना। थर्मल एनर्जी जो आप देखते हैं उसको हम एक्सप्लेन करते हैं, और फिजिकल इक्विलिब्रियम है। यस,
हेलो
फिजिकल
सर, एम आई
इक्विलिब्रियम में,
ऑडिबल?
फिजिकल इक्विलिब्रियम में जो हम
हाँ सर,
एक्सप्लेन करते हैं वो सॉलिड टू लिक्विड
हाँ सर।
इक्विलिब्रियम होता है, और लिक्विड वेपर इक्विलिब्रियम होता है, और सॉलिड वेपर इक्विलिब्रियम। ये तीन कंडीशन होती है, इसके
हाँ,
अकॉर्डिंग फिजिकल इक्विलिब्रियम को हम डिफाइन करते हैं।
यस सर, यस सर, हाँ हाँ हाँ, यस। दैट मीन्स आई कैन गिव एग्जांपल नाउ, लिक्विड टू वेपर, एंड सर कैन यू प्लीज, हेलो सर।
यस,
और सर मतलब थर्मल इक्विलिब्रियम में क्या होगा?
थर्मल इक्विलिब्रियम में कोई भी, जैसे आप कंडीशंस को फॉलो करते हैं, जैसे थर्मल एनर्जी है बिटवीन टू और मोर सब्सटेंस दिए आर इक्वल इन नेचर, ए और बी, ठीक है। तो उसका हम
ओके।
हीट फ्लो देखेंगे, तो हीट फ्लो ए और बी के अकॉर्डिंग
Oh,
देखेंगे।
yes, sir. Yes,
कोई
sir.
भी
Yes, sir.
फिगर,
That means suppose A are in temperature of 25 degrees Celsius, whereas B are in temperature of 35. That means if we contact this, then B से A तक होगा, और मतलब around
यस
30 डिग्री सेल्सियस में मतलब इक्विलिब्रियम में हो जाएगा. Yes,
यस, वो
that is called
हीट का जो
thermal.
फ्लो
हाँ
होगा
सर.
वो
That
चेंज होगा,
means
वही कंडीशन थर्मल इक्विलिब्रियम में आ जाती है।
हाँ सर. Yes sir. Thank you.
और
हाँ सर.
फिजिकल
That means
इक्विलिब्रियम में हम तीन कंडीशन को डिफाइन करते हैं,
हाँ.
सॉलिड इक्वल
That means
इक्विलिब्रियम,
हाँ
लिक्विड वेपर
हाँ
इक्विलिब्रियम, और सॉलिड
हाँ
वेपर इक्विलिब्रियम। ये तीन कंडीशन होती
हाँ सर.
है फिजिकल इक्विलिब्रियम में।
हाँ सर. Yes sir. Yes. Yes. Yes sir. Definitely. ठीक है सर. थैंक यू. ये मतलब भूल ही गया था मतलब. हाँ सर, अभी ठीक हो गया.
नो प्रॉब्लम। नेक्स्ट
हाँ
हम
सर.
देखते हैं, जो अभी आपने डिस्कस किया था, ये केमिकल इक्विलिब्रियम। मेन रीजन देखेंगे, केमिकल इक्विलिब्रियम में हम डिफाइन करेंगे बैकवर्ड रिएक्शन और फॉरवर्ड रिएक्शन, उनको डिफाइन कीजिए केमिकल इक्विलिब्रियम को।
ओके सर. यस. So suppose I am taking this reaction A plus B to suppose C plus D. ओके. अगर मेरा वॉइस क्लियर नहीं आएगा तो सर आप बोल देना. हाँ, ठीक है.
यस
तो A
यस,
प्लस बी तो C प्लस डी, मतलब वहां पे राउटर है, यहाँ पे मतलब राउटर नहीं है, ब्रॉडबैंड नहीं है, इसलिए मतलब थोड़ा खराबी है.
कोई नहीं कोई नहीं,
ओके.
करिए।
सो so here that means forward reaction is, that means from left to right, which reaction is proceeding, that is called basically this reaction is called forward reaction, whereas right to left, that is called, which reaction taking place, that is called backward reaction. Okay. Suppose rate of forward reaction. Okay. Am I audible, sir? Rate
यस
of,
यस, ऑडिबल, नो प्रॉब्लम, कैरी ऑन।
हाँ सर. Rate of forward reaction is directly proportional to rate of forward reaction is directly proportional to concentration of A, that means active mass of A and active mass of B. Okay. Whereas for proportionality constant Kf, we are putting Kf, that means this is a rate constant. Okay. So that is the rate of forward reaction. Whereas a rate of rate of backward reaction proportional to backward reaction participating C and D only. So therefore rate of backward reaction is equal to concentration of C and concentration of D. Okay sir. So concentration of C and concentration of D, and it should be equal to Kb C and D. And sir, at equilibrium, rate of forward reaction is equal to rate of backward reaction. So that means rate of forward and rate of backward, that means Kf is equal to concentration of A, concentration of B, Kb, concentration of C, concentration of D. And now this K, we are separating that constant to the same side, and this concentration term to the other side. And now it will become Kf by Kb. We can take K, concentration of C, concentration of D, concentration of A, concentration of B. That K is called basically equilibrium constant. Yes, sir. That K is called equilibrium constant. Sir.
Yes.
Yes, sir. Yes, sir.
बैकवर्ड रिएक्शन और फॉरवर्ड रिएक्शन के लिए अगर हम ग्राफ बनाएंगे, कंसंट्रेशन और टाइम या कंसंट्रेशन और इक्विलिब्रियम के लिए क्या आएगा, और कंसंट्रेशन टाइम के लिए क्या आएगा, बैकवर्ड फॉरवर्ड का ये ग्राफ.
Okay, sir. Suppose I am taking putting this graph. Here we are putting concentration term, and here I am putting time. Okay. So at some time, that means only at zero. That means at zero. That means at initial time. Okay, at initial time, only reactant, that is A and B is there only. Okay, that means I am putting just reactant. Only reactant is there. So when the reaction is proceeding, that means reactant concentration is slowly decreasing, and whereas from the reactant we are getting the product. So therefore product concentration is also, therefore the product concentration is increasing, whereas the reactant concentration is decreasing. So therefore reactant concentration is like reactant is decreasing, whereas product concentration is increasing with time. And at some time, after some time, that means after around 1 hour, you can take this reactant concentration and product concentration become equal, and that means from the reactant we are getting the product, at the same time product we are getting the reactant at the same rate, and this time is called basically equilibrium. Is it okay? This is the equilibrium condition. Sir. Is it correct, sir?
Yes.
सर बोर्ड विजिबल हो रहा है ना?
Yes, yes, no problem. Yes, clear. अदर वन आल्सो कंडीशन दी हुई है, उन कंडीशन के अकॉर्डिंग अगर ग्राफ बनाएंगे, जैसे एट इक्विलिब्रियम द कंसिडरेशन ऑफ ईच ऑफ द रिएक्टेंट एंड प्रोडक्ट बिकम कांस्टेंट. 1 point.
At equilibrium, the concentration of each of the reactant and product,
each of the reactant and product become constant.
This one, sir.
Yes, 1 point. Yes, 1 point. Second point है, when reaction attain equilibrium at certain temperature and pressure, so del G is equal to 0. Yes. Third point है, chemical equilibrium can be achieved from the either direction.
Okay, yes, sir.
अब इस पे क्या ग्राफ?
Yes, sir. That means सर, मतलब इन कंडीशन, मतलब डेल्टा जी इक्वल टू 0 ना, मतलब मैंने क्वेश्चन समझा नहीं ठीक से.
3 कंडीशन मैंने आपको बताई हुई.
एक तो कंसंट्रेशन टाइम, ये तो मैंने लिख दिया,
ये हो गया, ठीक है. और दूसरा है व्हेन रिएक्शन अटेन इक्विलिब्रियम एट सर्टेन टेम्परेचर एंड प्रेशर del G इक्वल टू 0.
ये क्या होगा?
सर्टेन टेम्परेचर पे हम देखते हैं ना, चेंजेबल रहता है। और थर्ड पॉइंट है केमिकल इक्विलिब्रियम कैन बी अचीव फ्रॉम द आइदर डायरेक्शन।
नो आइडिया सर दैट ग्राफ। ये मतलब मैंने भूल गया शायद ये लिंक का।
कोई नहीं,
सर
मैं
उसका
आपको
क्या
भेज
होगा
दूंगा।
डेल्टा जी का? हाँ सर आप एक बार भेज दीजिएगा। मतलब डेल्टा डेल्टा जी ये मतलब शायद भूल गया मैंने, मतलब अगर एक बार बोल देंगे तो हो जाएगा। मतलब ये भूल गया शायद मैंने डेल्टा
देखो,
जी का।
सर्टेन टेम्परेचर पे जो आपने ग्राफ बनाया है ना, आपने ये जो बैकवर्ड और फॉरवर्ड को मिला दिया तो उसके बीच में गैप आएगा। फॉरवर्ड रिएक्शन, बैकवर्ड गैप सर,
ओके
कंसंट्रेशन और टाइम के लिए। इस तरह से,
लाइक
हाँ
दैट।
इस तरह से, यस।
हाँ ओके।
एक तो ये ग्राफ
अब
बनेगा,
एक बार
और
भेजिए।
एक ग्राफ बनेगा जो अपसाइड और डाउनसाइड बीच में क्रॉस करेगा पहले ही, कंसंट्रेशन और टाइम।
मतलब सर लास्ट वन।
हाँ, इसमें
मतलब
जो आप देखेंगे तो डाउन नीचे से ऊपर, हाँ इस तरह से, इस, यस।
इस तरह से।
हाँ,
हाँ हाँ। यस यस यस। आप
ये
एक बार
तो
फिर से अगर, हाँ एक बार भेज देंगे।
यस।
ओके।
नेक्स्ट पॉइंट हम डिस्कस
ओके
करते
सर।
हैं, लॉ ऑफ मास एक्शन। व्हाट इज लॉ ऑफ मास
यस सर।
एक्शन, व्हाट द रोल ऑफ लॉ ऑफ मास एक्शन इन केमिकल इक्विलिब्रियम?
Okay, sir. Sir, law of mass action. According to law of mass action, that means the rate of that means the equilibrium constant, the rate of forward reaction or rate of backward reaction is directly proportional to the concentration of the uh, reactant or product with the power raised to the coefficient. That is called basically a law of mass action. Suppose I am taking A mole of A and B mole of B and C mole of C forming D mole of D. Okay. So rate of forward reaction is directly proportional to Kf, concentration of A, here coefficient is A, so to the power A, and concentration of B to the power B. And similarly, rate of backward reaction is equal to Kb, concentration of uh, C to the power C, concentration of D to the power D. Yes, sir. So here, from here, rate of forward, rate of backward will be equal, and we will get K is equal to, I am just skipping first part, D to the power D divided by A to the power A, B to the power B. Yes, sir. That means according to law of mass action, the rate of forward or backward reaction directly proportional to basically the uh, concentration of the reactant or product with the power raised to the coefficient of it. Yes, sir. That is the law of mass action. Is it correct, sir?
यस। व्हाट इज इक्विलिब्रियम कांस्टेंट?
Sir. Equilibrium
What are the
constant is
main
the ratio
most
of
important point about the equilibrium constant?
yes, sir. That means equilibrium constant is that is the rate of forward reaction is equal to the uh, ratio of rate of forward reaction and the rate of backward reaction is basically called equilibrium constant. Is it okay, sir?
Yes.
Ratio of rate of forward reaction is equal to the ratio of this. Okay. Whereas और सर क्या पूछा आपने नेक्स्ट क्वेश्चन?
What are the most important point about equilibrium constant?
Okay, sir. Okay. So when K, suppose K is, ये कैसे बोलूं मैं, K is greater than 1. Okay, let I am taking K is greater than 1. That means the product of the that means product formation is larger. Okay, K is that means product formation is more than the reactant. So that's why reaction will moving towards backward direction. That we can tell, that means from product reaction will moving towards backward direction if the K greater than 1. Whereas if K less than 1, K less than 1, then the reactant concentration is higher, then reaction will be taking place to forward direction. Is it okay, sir? Reaction will be taking place to forward direction. हाँ सर.
Yes.
और हाँ सर, यही होगा पॉइंट.
Yes, forward and backward reaction. Yes, product upon reactor, reactant upon product. Yes.
हाँ सर. और सर मतलब if we talk about factor affecting the equilibrium constant, okay, factor affecting the equilibrium constant, that means first temperature will affect the, that means temperature will affect the equilibrium constant. Okay, yes. If the reaction is endothermic in nature, if the reaction is endothermic in nature, that means endothermic means we are giving temperature. Okay, if we are giving temperature, so that means the rate of
It's carry on, I think network issue.
हाँ सर, सुन रहे हो अभी? Am I audible? Okay.
Yes, audible.
Hello.
Yes,
Okay,
yes,
sir.
carry on.
Suppose if temperature is, that means that means if the reaction is endothermic, that means delta H is positive. If we increase the temperature, that means the reaction will favor, that equilibrium will favor at high temperature. That means when the reaction is exothermic, then equilibrium will favor at high temperature. Whereas if the reaction is exothermic in nature, that means heat is evolving. Okay, then the reaction will be favored at low temperature. Is it okay, sir? Am I audible? Okay.
Yes, yes, audible.
So that is
yes,
the
no problem.
first, that is the main factor. That means temperature factor. If the reaction is endothermic in nature, then the equilibrium condition will favor at high temperature. Whereas if the reaction is exothermic in nature, then the reaction will favor at low temperature. Okay. Another factor, that is the, what it is called, stoichiometry of the reaction also, that will also affecting the equilibrium constant. Whereas that means क्या बोलते हैं उसको, mode of representation of the reaction also, that will affect also the equilibrium constant, sir. Is it okay, sir? Mode of representation means, suppose I am taking H2 plus I2 equilibrium with 2 mole HI. So if I take this equilibrium constant is Kc, and when we put this reaction like that, 2 mole HI forming H2 plus I2, then the equilibrium constant Kc will be 1 upon Kc. Is it okay? That is also an important factor for Kc. Sir.
Yes.
First one is temperature. Second one is that mode of representation, and third one is the step of reaction also. Step. Okay. That step, that means if a equilibrium reaction taking place in multi-step, then this also determined. Okay, sir. And the stoichiometry of the reaction also. Sir.
Yeah, next one is, what is the difference between homogeneous and heterogeneous equilibrium?
Okay, sir. That means if the reactant and product, sir, if the reactant and product are in the same phase, then it is called homogeneous. If in equilibrium the reactant and product are in the same phase, then it is called homogeneous equilibrium. If the reactant and product are in the different phase, then it is called heterogeneous equilibrium. The main application of homogeneous and heterogeneous equilibrium are that is in catalysis process, we basically applied that things. Okay. If the homogeneous catalysis is there, then the reaction proceed very fast. But the main disadvantage of homogeneous catalysis is we cannot separate the catalyst. Okay. If the catalyst is in, that means different phase, then it is called heterogeneous catalysis. In heterogeneous catalysis, we can easily separate the catalyst after product formation. Yes, sir. That means the main application of equilibrium in what it is called catalysis process.
Yes. How many factors
Yes, sir.
affecting homogeneous heterogeneous equilibrium?
फर्स्ट फैक्टर तो सर टेम्परेचर ही होगा.
Yes.
फैक्टर सर होमोजेनियस एंड हेटेरोजेनियस इक्विलिब्रियम का दैट इज टेम्परेचर ही होगा. और क्या होगा?
टेम्परेचर, प्रेशर, कंसंट्रेशन.
टेम्परेचर आएगा. यस सर. टेम्परेचर आएगा और प्रेशर आएगा. यस सर. सेम थिंग.
टेम्परेचर, प्रेशर, कंसंट्रेशन.
टेम्परेचर, प्रेशर एंड कंसंट्रेशन. हाँ सर. ओके. बेसिकली हाँ सर यही होगा. यस.
What the unit of equilibrium constant?
Sir, basically equilibrium constant has no unit because it is the ratio na. That's why it has no unit. हाँ सर. But हाँ yes यही तो होगा.
क्या यूनिट होगा?
But मतलब it has no unitless है. ये तो रेशियो है ना.
यस यूनिटलेस.
रेट का रेशियो है इसलिए.
उनकी कोई ड्रॉबैक लिमिटेशन है इक्विलिब्रियम कांस्टेंट या हेटेरोजेनियस होमोजेनियस कैटलिस्ट?
हेटेरोजेनियस होमोजेनियस कैटालिसिस का ड्रॉबैक तो हेटेरोजेनियस होमोजेनियस no idea. Equilibrium constant. First thing that means it can sense na. No idea sir that one. I have to check that. This one no sir.
Homogeneous equilibrium in gaseous phase. Homogeneous equilibrium is solution phase. Equilibrium constant for various heterogeneous equilibrium. इनकी conditions क्या है? Explain करेंगे आप?
Sir, मतलब when I am taking, suppose I am taking one reaction that is hydrogen plus iodine. We are getting 2 mole each side. So hydrogen is in gas, that is iodine is in gas. Okay. So the first thing is that for solid and liquid substance, okay, for solid and liquid substance, we cannot, we take the active mass equal to active mass value equal to 1. Okay, because that means in solid and liquid phase, the density remains same. So, or it is an intensive property, it does not depend upon the mass. That means basically, so if in heterogeneous system, then basically the concentration of solid or liquid substance we have to take 1. Okay, whereas in that means in gaseous substance, suppose this one, that means Kc will be equal to Kc will be equal to concentration of each side ka square, concentration of H2 and concentration of I2. That is the main. हाँ सर यही होगा. हाँ सर. So suppose I am taking a H2 plus I2 with okay, this one. Suppose I am taking calcium carbonate. This is in solid form. Then calcium oxide that was in solid and carbon dioxide in gas. Okay. So if we take for this, that means equilibrium constant. So here equilibrium constant will be, suppose I am taking concentration of CaO, concentration of CO2 and concentration of CaCO3. Here that means since this is in solid and this is also in solid, so here concentration will be 1 and here concentration will be 1. So therefore Kc will be only equal to concentration of CO2. Is it okay, sir? For homogeneous and heterogeneous.
Yes.
हाँ सर. और क्या एक्सप्लेन करना होगा?
एग्जाम्पल एक्सप्लेन करने हैं. एग्जाम्पल क्या हो सकते हैं होमोजेनियस इक्विलिब्रियम
हाँ
में
सर.
सॉल्यूशन
हाँ सर, ये तो मतलब दोनों का बता दिया. और एक बता देता हूं मैं. मतलब we can take example of water also. Suppose we are taking example of water. That means 2 mole water liquid is giving hydrogen gas and oxygen gas. Okay, sir. 2 mole water is giving hydrogen gas and oxygen gas. So here Kc will be concentration of hydrogen, concentration of oxygen, and concentration of water square. But since the water is in liquid form, therefore Kc will be equal to concentration of hydrogen and concentration of oxygen only. Yes, sir. Is it okay?
Yes,
यहाँ
okay.
पे कुछ मिसिंग क्या? यहाँ पे मतलब ये होगा, 2 मोल आएगा, यहाँ पे स्क्वायर आएगा. हाँ सर, बैलेंसिंग में थोड़ा गड़बड़ी किया मैंने. हाँ सर. हाँ सर.
ली-चैलेटियर प्रिंसिपल क्या है? व्हाट द एप्लीकेशन ऑफ ली-चैलेटियर प्रिंसिपल?
Sir, Le-Chatelaar principle is basically, according to this principle, if a system at equilibrium is subjected to, suppose like change in concentration, change in pressure, or change in temperature, then the equilibrium shifted in such a way that means it undo the effect of the changes. That is called basically Le-Chatelaar principle. Suppose that means if we change the concentration of any concentration, pressure of or temperature of temperature, then the equilibrium will shift. That means it can shift to forward direction or it can shift to backward direction. Yes, to undo the effect of change. मतलब equilibrium, to maintain the equilibrium basically, it can move to forward or backward to adjust. Yes, that is called basically Le-Chatelaar principle. Suppose I am taking this reaction, N2 gas plus 3 mole hydrogen is giving 2 mole ammonia. Okay, sir. So N2 gas plus 3 mole hydrogen is giving 2 mole ammonia. Here, suppose first thing, that means if we change concentration, okay, if we change concentration, to changing the concentration, if we add the reactant, okay, if we change the concentration, that means if we add reactant this side, that means the product concentration will automatically increase. That means if we adding the reactant, then reaction will move to forward. Whereas if we add some amount of ammonia, the reaction move to backward. Yes, sir. That is the effect of concentration. That means if we added reactant, then the reaction will move to forward reaction. Whereas if we add some product, then the reaction will move to backward reaction. And suppose and then the next term is pressure. Okay, then the next term is pressure. In pressure, what we can tell, pressure is basically, if we increase the pressure, that means the reaction will shift to that direction. We know that from Boyle's law that pressure inversely proportional to volume. So if we increase the pressure, the reaction will move towards that direction where the volume is minimum. Okay, is like that. Therefore, if we increase pressure in this reaction, okay, suppose we are increasing pressure this reaction, so here that means volume is